Assalamualaikum. My name is Aisha Batul and my roll number is 16TE01. Today our lecture is 9 and today we'll be starting our new topic, that is DFT. We have always heard about DFT and signal systems and communication systems. Basically DFT is discrete fourier transform. Okay, discrete Fourier transform, we will be discussing about the discrete signals, about the digital signals that we have discussed in our video 1. Okay, I have a signal here that I am plotting. It's a sinusoidal signal. On x-axis I have taken t and on y-axis I have taken the amplitude. Okay. Now you can see that I am plotting only one spike of magnitude 1, -1 and 1. Okay, as it is in time domain, when I will plot it in the frequency domain, it will be only one spike. And let's suppose that I assume that after completing one cycle there is 10 millisecond time period, and in the frequency domain it will be of 100 Hertz frequency and the amplitude will remain the same, it will be 1. Now in time domain, representation of digital signals describes the signal amplitude versus the time. It is in the time domain. Whereas in the frequency domain, we discuss amplitude versus the frequency. We discuss the relationship between amplitude and frequency. That is, DFT establishes the relationship between time domain representation and the frequency domain representation. Okay, now we know that the Fourier transform is basically applied on the non-periodic signals, or we can say that a Fourier stochastic time is applied on the periodic and non-periodic signal. Okay, let's suppose that we have a digital Fourier transform. We plot signal as it is a periodic one. Okay, now I sketch some of the spikes. Somehow like this. It is n. Okay, from here to here I take the distance as capital N. It's x of 0. Here it is x of n. Okay, now basically what I am doing here is I am finding the value of the coefficient CK. Okay, it is a Fourier transform coefficient and we are deriving the formula that we will be using further in our lectures. Basically what we are trying to do here is that using this figure and using the and doing the calculations, we will be finding the value of we will be finding the formula for the discrete Fourier transform. Okay, now Fourier series expansion, we will be applying the Fourier series expansion on this figure. Okay, we have C of k. Now over the time interval t, and here it is t naught, x of t and e raised to the power minus j k omega naught t dt. Here we know that k is the number of harmonics and W naught we know 2 pi by T naught, and 1 over T naught is equals to F naught. So what we get here is 2 pi F naught. Okay, it is the W naught. Okay, now what we will do here, we will put the values here in this equation number 1. What we will get is C of k is 1 over T naught. We replace the integration over with the summation. Okay, now here n is equal to 0 to n minus 1 x of n, and here we will get e of minus j k and 2 pi by n, and here we will be getting n. Okay, now what we will do here is, now we will calculate C, okay, k n plus n. We will put here except k, we will be putting k equals to k plus n. Okay, sorry. Okay, what we will do next is we will expand okay, and we cancel out. Okay, we know that e raised to power minus j 2 pi n is equals to cos 2 pi of n minus j sine of 2 pi n, and it results in 1. So we will substitute the value here. It is c of k plus n. Okay, 1 over n, and here we will get n minus 1 x of n and e raised to power minus j 2 pi k n over n. Okay, this is the same equation as we have derived earlier. This one, c of k, you're seeing this is the same equation that we have derived now. See, it's the same. So we say that c of k is equal to c of k plus n, that is 1 over n summation n equals to 0 n minus 1, that is the previous value, e raised to minus j k 2 pi n over n. It is the final equation. This is the discrete Fourier transform equation that we will use further in our lectures. I hope that you have understood the lecture, and if there is any query you can comment in the comment section below. I hope you like it, and do me a favor, you can subscribe my channel too.